Hi everyone, so we're going to be simplifying radicals today that have coefficients in front. It's really nothing too crazy compared to what we did yesterday, but we are going to need to use the skills that we learned yesterday and apply them to today's lesson. So let's get started. So the first thing that I just want to review again is it is really important that you have this perfect square list. If you did not memorize it, if you memorize it, that would really be the best case scenario. It's a really easy list to make on your own. If you just say, okay, what's 1 times 1, 2 times 2, 3 times 3, 4 times 4, and have that listed out. But we are going to be using the perfect square list again today. We need to know what numbers are perfect squares and just reviewing our division skills and stuff like that. Okay, also we still need to know the parts of a radical. So we know that we have our radical symbol, we have our radicand underneath, our index, which in this lesson we're not going to have an index. I mean, it's going to be 2, but we're not going to see it. And then the coefficient in front. So just like I said yesterday, whenever you have a coefficient, like say you had something like 5x, that's really saying 5 times x. So if you have something, I'm just going to give a little example down here. If you have 5 radical 3, this is really saying 5 times, so that's a old school multiplication symbol, radical 3. So we are multiplying when there's a number in front. So please keep that in mind. Okay, so when simplifying radicals with coefficients, first we're going to simplify the radical by finding the largest perfect square, or the other method where you find a perfect square and then keep simplifying. I'm going to be doing finding the largest perfect square, just like we did yesterday. So that's going to be the first thing that you do before you do anything else. You're going to just simplify the radical. And then once you're done, you're going to multiply the coefficients that you have left. So basically anything that's not underneath a radical symbol, you're going to be multiplying together in the end. So let's take a look at an example. So we want to express this in simplest radical form. We have 3 radical 56. So remember, this is saying 3 times radical 56. So the first thing that we want to do is we want to simplify radical 56. So we need to find the largest perfect square that can go into it. If you want, write your list on the side or just have it ready so you can just do process of elimination pretty much. So 49 can't be divided into 56, 36 can't be divided into 56, 25 can't be divided into 56, 16 can't, 9 can't, but 4 can. So that is our largest perfect square that can go into 56. So we're going to separate that out into radical 4 and radical 14. So 4 times 14. And if you want to do that little division on the side, that's fine, so you know where those numbers are coming from. 56 divided by 4 is 14. Okay, so now let's simplify this square root of 4. Square root of 4 is 2, because 2 times 2 is 4. And I'm going to just bring down that 14. Let me just make that a little neater. Okay, but we still have this 3 in front, right? So what we're going to do is we are going to multiply that to the 2, because they're both out of a radical sign. So they're technically both coefficients, so we're going to multiply them together. And we're going to get, I'm going to just write multiply. And we're going to get 6, and then just bring down that radical 14. Okay, so all we did was simplify a radical and then multiply those coefficients. So make sure to bring down that 3 though, because a lot of students forget about it, but you have to bring it down, you have to multiply it. Okay, let's look at another example. Expressed in simplest radical form, same thing here. 5 times radical 112. The first thing that we want to do is simplify that 112. So you're going to search for that largest perfect square that can go into 112. And hopefully after you search, you're going to find that that is 16. And 16 times 7 gives us 112. Now let's simplify this 16 and we get 4. Then I'm going to just bring down that 7. And then I'm going to take this 5 and multiply it to that 4. So we're going to multiply. And we're going to get 20. I'm going to just bring down that radical 7. So step 1, simplify that radical, finding that largest perfect square. Simplify the perfect square. Don't forget to do that. And then multiply your coefficients. All right, let's take a look at one more example. So we have 6, and then we have 6 radical 175. Remember, that's really 6 times radical 175. So let's just start by finding the largest perfect square that goes into 175. Now, whenever it ends in a 5 or a 0, I always think, okay, can it be divided by 25, and can you get a whole number from that? So that's kind of just the thought process in my head. That's not always the case, but that's always the first place that my brain goes is, okay, is this a multiple of 25? And in this case, it is. So this is square root of 25 times 7. So 25 times 7 gives us 175. So I'm going to just do that over here. But do that process of elimination if you cannot figure this out. Okay, so now let's simplify. Square root of 25 is 5, and then I'm going to bring down that radical 7. Now we have that 6 in the front that we can't forget about. I'm going to circle it, bring it down, and we're going to multiply. 6 times 5 is 30, so we're going to get 30 radical 7. So simplify your radical using that perfect square, and then just make sure that you multiply your coefficients in the end.